Hey guys, this is question 8B from fall 2015 midterm. I'm going to make this as quick as I can, so here it goes. Question 8B is looking for four things, guys. Number of valence electrons, molecular electronic ground state, bond order, and which of the two is the stronger compound, right? So we have O2 and O2 plus for question 8B, and it's asking which has a stronger bond. Okay, first thing to start off with, notice what the atomic number will be, right? So atomic number for oxygen, according to our periodic table, is 8. So remember, I'd write that at the top first. Z is greater than or equal to 8. That really will determine our molecular orbital theory diagram. So first things off, the number of valence electrons. Oxygen has 6 valence electrons, right? And there's 2 atoms of oxygen, so 6 electrons times 2 is going to give you 12 electrons. For O2 with no charge, O2 plus, same process, 6 times 2 is 12, minus 1 electron, because the plus charge means that we're losing an electron, so that would give us 11 electrons, right? Okay, so for step 2, when they're asking for the molecular electronic ground state, we're going to have to use the molecular orbital theory, right? So to fill out things, we're going to start off with atomic orbitals for O2 and O2 plus. We set it up with a 2s and 2p. 6 valence electrons in oxygen, right? So we're going to have the 2s shell is going to be filled, 2, and 2p, 3, 4, 5, 6, right? And same thing with O2 plus, 1, 2, 3, 4, 5, 6. All right, good. So in sum, we have 12 electrons, right? So for the molecular electronic ground state for O2, we're going to fill in our molecular orbital theory diagram, and it will give us sigma 2s, sigma star 2s, which represents the antibond. Anytime there's an asterisk, that represents antibond in the molecular orbital theory diagram. So then we have sigma 2pz, which is below, notice it's below the pi 2px and pi 2py because z is greater than or equal to 8. Then we have our pi star 2px, pi star 2py, and then sigma star 2pz. Okay, so after filling this in, right, we find the sum of these two. 6 plus 6 is 12. So we're going to fill it out from top to bottom, right? Because energy is increasing. So basically when you fill it from top to bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for O2. Then it corresponds to the molecular electronic ground state. You basically just denote it using the sigma and pi bonds. And don't forget to include the antibonds. So basically, when you're filling it in, the exponents just represent how many electrons are in that shell. So the sigma 2s, there's 2 electrons here, so that's squared. And basically that corresponds to how your molecular orbital theory diagram will look like, right? And then for O2 plus, same thing, but the plus charge indicates that we are losing an electron, right? So we're going to take off 1 electron from the top, right? So we'll take out 1 electron from pi star 2py. And this is something important to remember because when you're taking out an electron from an antibond, that will indicate a stronger bond for that compound, right? So that's how we get the molecular electronic ground state. And for bond order, it's basically 1/2 number of bonded electrons minus number of antibonded electrons. So for O2, the number of bonded electrons are 2, 4, 6, 8, right? And then the number of antibonded electrons are 2, 3, 4 for O2, right? Okay. So then after doing that calculation, that will give you 2. For O2 plus, remember how we lost an electron? everything stays the same except the number of anti-bonded electrons. So now that reduces to 3. So 1/2 times A minus 3, that gives you 2.5. Sum things up. 2.5 larger bond order indicates the stronger bond. And since O2 plus O2 plus with a plus charge has a stronger bond, as one electron is removed from an antibond. All right, good job, guys.